So I want to thank you all for joining this session today. I hope you had a good Thanksgiving weekend. For me, the weekend was pretty good. I don't know if there's any college football fans out there, but I'm a University of Michigan alum, and I'm a big Michigan football fan. Yeah, go Blue. So we just beat our arch rival, Ohio State, for the third time in a row over the weekend. So I hope there's no Ohio State Buckeye fans out there who are going to take my session score today. Sorry for that. So just to make sure you're all in the right place, this is CMP105. We're going to talk about how to use capacity blocks, which it's a new EC2 provisioning option to get GPU capacity to run machine learning workloads. We'll also talk a bit about how capacity blocks work with EKS as well. And just as an introduction, so my name is Jake Siddle. I'm a product manager within EC2. I'm part of the capacity products team, and I'm the product manager for this new capacity blocks product. So just to provide an overview of what we're going to cover today, so I'm going to start by setting the stage, going over why customers choose AWS for their machine learning workloads, and I'll talk about like the different machine learning service offerings that we have within AWS. I'm going to focus on, after that I'm going to focus on EC2 provisioning options for accelerated hardware, specifically GPU instances. And then from there, I'm going to narrow in on this new capacity blocks product and talk about how you can use this product, when you should consider using it, sort of like a framework for how you should consider using capacity blocks. And then I'll finish off with a live demo of the capacity blocks product. And just to kind of, as sort of a teaser, I was just looking this morning at like the capacity blocks that we have available right now. So capacity blocks are currently available for P5 instances, which feature NVIDIA H100 GPUs. We have capacity available starting as early as tomorrow, and the prices currently start 25% below the on-demand rate, if you want to take a look after this session. All right, so I don't think I can overstate how machine learning is powering breakthroughs that are really impacting every aspect of our lives. And the application of machine learning to develop new products and transform businesses has really been accelerating over the past year or so. At AWS, we're super proud about the role that we've played in democratizing machine learning, making ML accessible to pretty much anybody who wants to use it. And that's why over 100,000 customers are running their ML workloads on AWS today. Over the past year, generative AI has really taken the world by storm, especially now that the general public has experienced directly the power of the latest generative AI models through consumer apps like ChatGPT. And we're seeing more and more customers now who are building and deploying generative AI applications for a variety of use cases. Really broad range of use cases that we're seeing, from like text generation for productivity applications that can improve worker productivity, to like applications where customers are enhancing creativity, like with music generation and video generation apps. And there are so many more in between, but we know we're just scratching the surface of what generative AI can do these days, and we're super excited to continue working with our customers to identify new applications and figure out where Gen AI can add value. So with that context, let's talk a bit about why customers are choosing AWS for their ML workloads and the different service offerings that we have available. You may have seen this chart before. We use it pretty often, so I'll just kind of briefly summarize this. So AWS has the most comprehensive set of AI and ML services for all skill levels. We want to make sure that we offer many different options for customers to choose from, so that they always have a solution that's sort of optimized for their specific use case, regardless of the customer size or industry. And we kind of organize our different offerings into these three different layers to kind of help customers kind of think about what we have available. So in the bottom layer here, we have our ML frameworks and infrastructure. So this layer includes our EC2 instances powered by accelerated hardware, things like GPUs or custom ML silicon. We also have our these instances are interconnected by high-speed network interfaces. Then we have our frameworks that are optimized to run on this accelerated hardware as well. We support popular frameworks like PyTorch and TensorFlow that come prepackaged in our deep learning AMIs, deep learning containers that make it easy for anybody to get started with these instances. And then moving up in the stack, we have Amazon SageMaker, which is a managed service, makes it super easy for any developer to build, train, and deploy AI models on AWS. And this is a really good option for customers who are looking to just focus on the data science. They want AWS to manage the heavy lifting of like the infrastructure management for them. And then at the top layer, we have our AI services. So within this layer, we have like specific sort of task-specific, services that are powered by foundation models that Amazon has developed, like for specific use cases, we have like Amazon Code Whisperer, which is a code generation application that helps developers code more efficiently. We also have Amazon Poly, which is a text to speech generation application. And these services are super easy to access just through simple API calls on a pay-as-you-go basis. In this layer, we also have Amazon Bedrock. I know there's been a lot of buzz about this year, but it's a new service where customers can now access the latest foundation models from leading AI companies like Anthropic, Stability AI, again, through simple API calls. One thing I do want to mention this layer, I'm not sure if folks have heard about like our new Party Rock app that we just launched a couple weeks ago. Highly recommend you check it out if you haven't already. But it's a new like Amazon Bedrock playground where you can create like a simple Gen AI app in just literally a few minutes. It's kind of cool, kind of fun to play around with. So for this session, I'm going to focus on this ML frameworks and infrastructure layer, specifically EC2 compute and GPU-based instances through EC2. So just to give an overview of the instance options that we offer for machine learning workloads, I'm going to start with our GPU-based instances. So we kind of separate these by training and inference. So we have our P4 and P5 instances, which are optimized for deep learning workloads. They're especially optimized for deep learning at scale, like customers who want to train deep learning models on distributed clusters. These instances have really high networking performance, and they're optimized for that. So we have our P4 instances, which feature NVIDIA A100 GPUs, and then our P5, which feature H100 GPUs. And the P5 instances, these are the instances that we currently offer through capacity blocks. We'll talk about this a bit more later. But these are the highest performing instances for deep learning that are currently available in EC2. And then on the inference side, we have GPU-based instances, our G5 and G5G instances. So G5 features the NVIDIA A10G Tensor Core GPUs. These are great instances for inference performance, and they're super flexible. They come in many different sizes, so you can kind of right size for your workload. They can also support like small machine learning workloads as well. And then G5G features NVIDIA T4G instances, and they're paired up with Graviton 2 CPUs. So this can be like a really cost-effective way, a cost-effective option for running inference workloads if you want to use NVIDIA libraries. So we're going to keep investing in our GPU instances. We want to launch the latest and greatest GPUs that we can. But we know that we have a lot of customers who are looking for like different options as well, like customers who want to train workloads on like custom ML silicon as well. And that's why we partnered with Habana Labs, which is an Intel company, to launch our DL1 instances. So DL1 instances feature Habana Gaudi custom ML accelerators. And this can be a really cost-effective option for training large ML models as well. You can use the Synapse AI SDK, which is integrated with PyTorch and TensorFlow to build your models on DL1. And then finally, AWS is continuing to invest in our own ML silicon to kind of push the performance and price performance of machine learning training and inference in the cloud. So we have our Trainium line of instances for training, and then our Inferentia 1 and Inferentia 2 instances for inference. And these instances offer the best price performance for training and inference in the cloud. You can get started with these instances using our Neuron SDK, which is compatible, or it's integrated with TensorFlow and PyTorch as well. So I want to really highlight our P5 instances, which, as I mentioned, are currently supported by capacity blocks. We just launched P5 in July. And as I mentioned, these are the highest performing instances currently available for deep learning training. These instances are powered by, or they come in one size, and each instance has 8 NVIDIA H100 Tensor Core GPUs. These instances, they're capable of up to 4 times higher performance and up to 40% lower price performance compared to our previous generation GPU instances. And a single instance is capable of 16 petaflops of computing performance, and it has 640 gigabytes of high bandwidth memory. These instances also can produce 3,200 gigabits per second of networking performance, which is super important for our customers who want to scale out multiple clusters of these instances to run distributed training workloads for larger and larger models. We know model sizes, parameter numbers are continuing to increase, so networking performance for efficient scaling is super important. So on that line, when we designed these instances, we wanted to make sure we weren't just thinking about the server level performance, but we thought about the instance performance in the context of the data center. And that's why we continue to invest in our EC2 Ultra Cluster designs. So P5 instances are deployed in our second generation Amazon EC2 Ultra Clusters, which are specifically designed for high performance, large scale model training. So an Ultra Cluster can now feature include up to 20,000 H100 GPUs. And they're all connected via non-blocking petabit scale network infrastructure. You can get consistent low latency connectivity between all the instances that are part of an Ultra Cluster using our second generation Elastic Fabric adapter. And then also your instances that are launched into an Ultra Cluster can access our high performance managed storage offering with FSX for Lustre with really low latency and high throughput. That way, as you're running your training workloads, you can make sure that your instances remain saturated with data, and your storage doesn't become a bottleneck for training efficiency. All right, so I know this all sounds great, all of our infrastructure offerings are pretty cool. But a challenge that we're constantly working with our customers to overcome is how they can get GPUs, specifically P4 and P5 GPUs that they need, when they need them and where they need them to run their ML workloads. Over the past year, there have been some really exciting breakthroughs in the experiences and capabilities of foundation models. And because of that, there's been a big uptick in demand, across the entire industry, for GPUs to train and deploy these types of models. So this growth in demand has really outpaced supply of GPUs across the entire industry, making GPUs a scarce resource pretty much anywhere you go. So this growth, as a result, it's been really hard for customers kind of anywhere they go to get access to GPUs just when they need them. So what we're hearing is customers are often having to wait in long lines, wait long lead times to get GPU capacity, often with kind of unclear dates of when they're actually going to receive it. And then once customers actually get that GPU capacity, they're often having to hold on to it even when they're not using it, just to make sure they still have it again the next time that they need it. And that's sort of perpetuating this scarcity problem, because there's a lot of GPU capacity that's just sitting around idle across the entire industry. So I want to talk about the provisioning options that we have available for GPU instances, P4 and P5, or actually this is really focused on P5 right now, instances in EC2 that when used correctly can really help you sort of mitigate these scarcity challenges or bypass them entirely. So we have on-demand capacity reservations, or ODCRs for short, which many customers are using right now for GPU capacity in EC2. And what ODCRs allow you to do is you can reserve a specific instance type in a specific availability zone for however long you want. You only pay for this reservation when the instances aren't running. And as long as you hold on to that reservation, you're going to have assurance that you can launch all the instances that you've reserved. The caveat to ODCRs is when you create an on-demand capacity reservation, it's subject to capacity availability at the time that you create it. It's very similar to on-demand instances. So it can take a while to get an ODCR in the first place. They're really recommended for GPU instances like P4 and P5 instances if you have sort of long-term sustained usage where you want to hold on to this reservation for a long period of time and you're willing to plan in advance to get that capacity in the first place. Another thing to mention about ODCRs is you can offset the cost of the reservation with savings plans to get a discount on the on-demand rate. But savings plans do require like a 1 or 3 year term commitment. The other provisioning option I want to mention here are spot instances. So spot instances have really been useful for a lot of customers who are trying out P5 instances lately. So spot instances offer a pretty steep discount over on-demand rates because EC2 can interrupt the workload at any time to take that capacity back when we need it. But this is a really good option if you have workloads that can tolerate these interruptions. So where we see a lot of customers using spot instances for P5 is if they want to try out the P5 hardware, like in a really sort of low stakes kind of cost-efficient way, this is a good thing to try. Like if you have custom mommies where you want to check the compatibility with these instances, or you have libraries where you want to check configuration with this hardware, spot can be a good option to try. But again, it's subject to capacity availability at the time that you provision these instances, just like ODCRs. And now we have the subject of this conversation, of this talk here. EC2 capacity blocks for machine learning are a brand new provisioning option that we just launched earlier this month, specifically for GPU instances. And right now they support P5 instances in the US East Ohio region. So what you can do with capacity blocks is you can reserve GPU capacity starting on a future date for the amount of time that you're going to need. So you can, this option is really like more flexible and elastic than ODCRs because you can reserve capacity with shorter lead times, and you don't have to hold on to it kind of in between the burst of capacity that you need for specific workloads. So you can reserve a capacity block in as little as 1 day, or you can even sometimes reserve a capacity block the same day, or you can reserve it for up to 8 weeks into the future. The more time flexible you are when you're reserving the capacity block, the better chance you have of finding an available time slot that we have to book. Capacity blocks pricing, it's dynamic, so it's based on supply and demand. Sometimes it can be higher than on-demand rates. Other times it can be lower. As I mentioned at the start of this conversation, we currently have capacity blocks for P5 instances starting around 25% below the on-demand rate. So I'm going to focus in on capacity blocks for the remainder of this session here, kind of talk about how you can use it and go from there. So how exactly do capacity blocks work? So it's sort of like booking a hotel room, actually. So you start by defining your date window, your date range when you're looking for capacity within. Sort of like if you're looking for a hotel room, you're going to search across a range of dates to kind of compare different hotel options, hotel prices, look at different rooms. And then you also provide the number of instances that you want to reserve and the duration of time that you want to reserve them for. Sort of like if you're comparing, or you have like a specific hotel room size in mind, like you want a couple queen beds or a king bed or a suite. Once you provide these specifications, then AWS or EC2 will show you time slots when we have capacity available right now to book. Just like an online booking tool for hotels like Expedia or Hotels.com, these time slots are visible right in our AWS management console in real time. And you can book available time slots whenever you want. You get an immediate confirmation that time slot you've booked is confirmed and that capacity is going to be available for you. So capacity blocks are super flexible because we offer like a range of duration and size options. So they can fit a bunch of different use cases. For example, you can reserve as few as a single P5 instance for up to 14 days, which is really useful if you just want a single instance for a set of training, a set of experiments or tests that you want to run. Capacity blocks can also scale up to 64 instances, and that's 512 H100 GPUs. That's a ton of computing power. And that makes them useful for fairly large-scale training runs. You can reserve 64 instances to up to 14 days. You can reserve back-to-back capacity blocks if you want. There's no restriction on how many capacity blocks you reserve consecutively. And then also, in addition to large-scale training, we have a bunch of sizes in between as well. Say you want to fine-tune an ML model or train a small task-specific model. You could reserve a capacity block of 4 or 8 instances for a few days if you'd like. And then lastly, capacity blocks can also be useful if say you have a product launch coming up and you expect a burst of inference demand. And you want to make sure that you have enough GPUs to serve those inference requests without your end customers experiencing an outage. Capacity blocks can be useful to schedule additional GPU capacity around the time of your product launch. to serve those inference requests. So we've been hearing from a bunch of customers who are really excited about this new Capacity Blocks product. What we've been hearing is that Capacity Blocks allows customers to operate with these like precious GPU resources in a more elastic way than has really been possible across the industry prior to this. As an example, Leonardo AI is a generative AI startup out of Australia. They use a variety of Gen AI models to help their end customers produce like production quality visual assets for things like video games. And they've been telling us that they're really excited about Capacity Blocks because they no longer have to hold on to these instances all of the time, which like results in a bunch of waste. And they have more flexibility to use like the right instances for the right jobs. And that value is going to continue to increase as we introduce more instance types with this model as time goes on. So I want to talk briefly about how you can avoid waste with Capacity Blocks. So before we had Capacity Blocks, what we heard from customers was a lot of times they would kind of use ODCRs to reserve up to what their peak needs were expected to be over some time period, even if they had like bursty kind of intermittent like peaks over some period of time. And they would combine these ODCRs with savings plans, to get a discount on the reservation. But that would result in a lot of wasted capacity kind of in between these peaks that was going unused. What Capacity Blocks allow customers to do now is you can reduce the amount of capacity that you're reserving with an ODCR down to what you think your baseline needs are going to be. And you can supplement that with Capacity Blocks just when you need that burst of capacity. And you can still cover your baseline ODCRs with savings plans to get a better rate there. And then you don't have all the wasted capacity kind of in between your peaks with Capacity Blocks. So a good example of like how a customer might use this is, say there's a customer who has a research team that needs like a couple P5 instances for over the course of a year for sort of a continuous queue of training or of testing and experimentation. They can use an ODCR for a couple of instances with a savings plan to operate really efficiently for those workloads. Let's say this research team wants to do a couple of model training runs over the course of the year. They want to fine-tune a model. Then Capacity Blocks are available for them to burst beyond their baseline to use additional capacity just for those specific workloads. So I want to quickly look at how the cost of Capacity Blocks can compare to ODCRs for a few different usage patterns. So as a baseline, we'll take a look at how much it would cost to use a single P5 instance over the course of a year. And for this exercise, I'm just going to assume that Capacity Blocks prices, although they're dynamic, I'm just going to assume that they average around the on-demand rate for P5 instances. And based on today's prices for Capacity Blocks, that's somewhat conservative. But we'll just use that as an assumption here. So as a baseline, let's take a look at what it would cost to hold on to a single P5 instance for an entire year if you combine a capacity reservation with a 1-year no upfront compute savings plan. So that would cost about $678,000. And if you plan to use that capacity, that instance for the entire year pretty efficiently, if you have close to 100% utilization, it's going to be more effective to use an ODCR than using Capacity Blocks because Capacity Blocks are not compatible with savings plans. However, if your usage becomes more intermittent, like if you have less than 100% utilization over the course of the year, say you, on average, are going to use that instance for 3 weeks a month or 2 weeks a month, then Capacity Blocks start to look like a more attractive option. You can see like 12% or 42% savings using Capacity Blocks for part of the time versus using an ODCR with a savings plan. I just want to caveat that these calculations are assuming the Capacity Blocks average around the on-demand rate of P5 instances. That isn't necessarily always the case, but it fluctuates above or below on-demand rates based on demand. All right, now I'm going to switch over and just do a quick demo, kind of show how to use Capacity Blocks from the console here. OK, cool. All right, so the first thing you want to make sure you do when you, so I'm going to just walk through how you actually search for and would purchase a capacity block from the AWS Management Console. So you want to make sure that you're in the Ohio region, which is currently the region that we support capacity blocks in. And then you'll navigate to the EC2 console page. So then once you're here in the EC2 page, you can go to the left-hand navigation screen and click on capacity reservations. So capacity blocks are considered, they're a type of capacity reservation, as opposed to like on-demand capacity reservations. So we have two types of capacity reservations now. And they're both visible from this console page. So in order to start searching for available capacity blocks, you click on Purchase Capacity Blocks for ML here on the top. There's also a button down here. And from this page, when you enter into this workflow, you can exit at any time. There's a couple of steps to actually reserving a capacity block. First, you want to search around and see when we have capacity available. And then once you find something that you actually want to book, that's when you purchase it. But you can search around. You can submit multiple requests. There's no commitment to actually buy something when you enter into this workflow. So currently, as I mentioned, we just support P5 instances. The default option from the console, the default platform option is Linux Unix. If you are interested in using something like Red Hat Enterprise Linux, that's available through our APIs. And then you want to select the total number of instances that you want to reserve. We have offerings ranging from 1 to 64. We have predefined options in powers of 2 in between that range. And then you select the duration of time that you want, anywhere from 1 to 14 days in 1-day increments. So I'm just going to keep it the default right now. And then the last thing that you select here is the date range when you want to look for capacity within. So it defaults to today's date and then 10 weeks out into the future as the latest end date. I'm just going to keep the defaults here for the initial search. So you can click this button, and you see right away what we have available. You see the start date is November 28th, end date's November 29th. We return a single block option or offering per search request. And this is always guaranteed to be the lowest price capacity block that we have in the date range that you specified. I'm going to take a look at a different block option here. Let's see if we have a 4 instance by 7-day block available. And I'm going to shrink the date range down. I'm assuming that I need to complete this workload by December 15th. So let's take a look again. All right. And so here's we have another block that's available on November 28th. You see the total upfront price of this capacity block. So the price of capacity blocks are charged upfront at the time that you reserve the capacity. You just pay a lump sum. I believe this equates to roughly 75% of the OD price of a P5 instance or 4 P5 instances for 7 days. So I'm going to proceed to the next step here. Let's assume that I'm happy with this capacity block and I want to purchase it. So you can add tags. So these are tags that would show up on the capacity reservation resource that you would create here. I'm going to skip that. And then we just have this summary page before you actually purchase the reservation. So I'm going to go ahead and purchase, type in confirm. All right, and it's as simple as that. Now the capacity is reserved. I have this reservation that starts on November 28th. You can see the details of the capacity reservation from this reservations overview page here, or this table. I have another reservation that I booked previously that's currently active, so you can kind of see the difference between a pending and an active reservation. So the state after you purchase a reservation, it goes into payment pending until the payment has been successfully processed. If you have like net 30 terms or something, your normal invoicing terms apply, so you just be charged after 30 days. And then once the payment has been processed successfully, the status will change to scheduled. And then you can see some additional information about your reservation here in this table. So you can see the start date and the end date for the reservation, and the total number of instances that you reserved. And available capacity will change once this reservation is active. You can see that in this active reservation here. This indicates how many instances you can launch right now into the reservation. So before a reservation actually starts, you can do some upfront work to kind of get prepared to launch your instances into the reservation so you don't have to eat into your reservation time once the reservation is active. So you can create a launch template targeting a capacity block while it's in payment pending or scheduled state. So I'm going to walk through how to do that here. In this workflow, it looks very similar if you were to launch an instance with the EC2 launch wizard as well into a capacity block. So I'm going to go ahead and create this launch template. Just make up a name here. All right, I'll select the P5 instance type. Choose my key pair. And then an important thing when you're creating a launch template or launching an instance into a capacity block is you have to go down into advanced details, and you want to select the capacity blocks purchasing option under purchasing options. You would do this this is a similar workflow if you were to use spot instances. And the reason why we have this is we want to make sure that customers don't inadvertently launch instances into a capacity block reservation, not knowing that at the end of the reservation, any instances that are still running are going to be terminated. So we want to make sure that customers are explicit when they're targeting these reservations, knowing about that termination behavior. So once you select capacity blocks, then you can select target by ID from the capacity reservation dropdown here. You need to target capacity blocks by their reservation ID. And that way we know which instances need to be evicted at the end of a reservation when it expires. And then we can select the capacity block that we want to target. So I believe this is the one that I just created, this EDE reservation. So I'm going to go ahead and target that. And then you can go ahead and create your launch template. So now we have this launch template. As soon as the capacity block is active, you can launch instances. They're just normal EC2 instances into the capacity block. You can stop and start them or terminate them and relaunch them over the course of your reservation. They're just normal EC2 instances for that entire duration. All right, I'm going to switch back here. All right, so the launch template compatibility with capacity blocks is really important if you want to use capacity blocks with an EKS cluster. So the way that you would do this, once you have this launch template that's created that targets your capacity block, you can go ahead and create an EKS self-managed node group configured to use that launch template that you just created. And what that does in the background is AWS will create an Amazon EC2 autoscaling group using that launch template that you specified. And once that autoscaling group is created, you can create scheduled scaling policies to automatically launch instances into that reservation at the reservation start time, and then scale down the autoscaling group when the reservation ends. So when you create these scaling policies for this ASG that is kind of paired with your EKS cluster, then when your reservation begins, EC2 will automatically start launching instances into your capacity block, and EKS will run pods on those instances, and you can queue up jobs ahead of time that can then automatically run in those pods. We do recommend that you use node termination handler to gracefully drain your pods at the end of your reservation. The node termination handler is aware of when your autoscaling group is going to start scaling in your instances at the end of your reservation, so that you can avoid disruptions to your workload if you still have a job running on your pods. So with that, here are some useful links to kind of get started with capacity blocks. I encourage you to check out capacity blocks in the AWS Management Console. It's super easy to get started, so there's a link here. We also have our capacity blocks user guide, as well as the EKS user guide for capacity blocks. The EKS user guide gives a really detailed step-by-step process of how to set up a self-managed node group in an EKS cluster. And then lastly, on the far right, we have a blog post that gives a pretty nice, simple walkthrough of how to use capacity blocks. So with that, I want to thank you all for your time here. If you can please take a moment to take the session survey, that would be super helpful. If you have questions, I'm going to hang out over here on the side, and would love to chat with all of you. But yeah, thanks a lot for your time.